This is a city that was supposed to be 170 kilometers long, house 9 million people, and have no cars, no roads, and no carbon emissions. It's called The Line, and right now, huge sections of it are quietly being scaled back, delayed, or cut altogether. This is the story of the most ambitious city ever proposed, and what happens when reality catches up with a trillion-dollar vision. Let's get into it. In 2021, Saudi Arabia unveiled a concept that seemed almost deliberately designed to break people's brains. Two parallel mirrored walls, 500 meters tall, 200 meters wide, stretching in an unbroken straight line for 170 kilometers across the desert. Inside, vertically stacked neighborhoods, high-speed rail running the entire length, and crucially, absolutely no cars. The pitch was that you could walk from one end of any given neighborhood module to essential services in 5 minutes, while a train could get you from one end of the entire 170-kilometer city to the other in 20. It was, and still is, one of the most audacious pieces of urban planning ever put on paper. The Line is the centerpiece of NEOM, a broader $500 billion development zone in northwestern Saudi Arabia, which is itself the flagship project of Vision 2030, the kingdom's sweeping plan to diversify its economy away from oil dependence. NEOM was supposed to include not just the line, but a floating industrial complex called Oxagon, a luxury mountain ski resort called Trojena, and a series of tourist islands. The line was always the headline act, the symbol, the thing everyone would remember. So how did we get from a mirrored skyscraper stretching to the horizon to what's actually happening on the ground right now? Let's start with the numbers, because they tell most of the story on their own. The original completion target for the first phase of the line was 2030. Recent reporting suggests the initial section actually likely to be finished by that date has been dramatically reduced, from an originally planned 170 kilometers down to a fraction of that, with some estimates suggesting only a few kilometers of the structure will be substantially complete. The originally projected population for that first phase, once touted in the hundreds of thousands, has reportedly been revised down to a much smaller figure. And the cost. Independent analysts and several media investigations have put total project costs for the line potentially running into the trillions of dollars if built out to its original full vision, a figure so large it dwarfs the GDP of most countries on Earth. NEOM's own leadership has acknowledged that funding structures have shifted, with the project now relying more heavily on external investment and debt rather than Saudi Arabia's sovereign wealth fund covering costs outright. So what actually went wrong? Or more precisely, what turned out to be harder than anyone modeling this on a rendering software ever accounted for? The honest answer starts with the fundamentals of construction economics. Building two parallel walls 500 meters tall across 170 kilometers of desert isn't like building a skyscraper. A skyscraper, however difficult, is essentially one extremely tall, extremely complex problem solved once and then repeated vertically. The line required solving that problem and then repeating it horizontally, continuously for over 100 miles, through varied and often difficult terrain, including mountainous sections in its northern reaches. Every kilometer of that mirrored facade needs its own foundation work, its own structural steel, its own logistics chain for getting materials to a remote desert location with limited existing infrastructure. Unlike a conventional city, which grows organically with roads and utilities built incrementally over decades, the line's entire premise required an enormous amount of infrastructure, power, water, waste, transportation, to be built essentially all at once, in a location where almost none of it previously existed. There's also a labor and expertise problem. A project this scale and this unprecedented in form doesn't have an existing playbook. There's no other 500-meter tall, 170-kilometer long linear city anywhere on the planet to draw institutional knowledge from. Every major decision, every engineering challenge effectively had to be solved from first principles, which is slow, expensive, and prone to the kind of scope revisions that have characterized the project's public history. Before we get further into the engineering, let's talk about why Saudi Arabia is betting so much on this in the first place. Vision 2030 exists because Saudi Arabia's leadership has been extremely candid about a structural problem. The country's economy is still overwhelmingly dependent on oil revenue, and oil revenue is not a permanent foundation for a modern economy, especially as the world gradually shifts towards renewable energy. NEOM, and the line specifically, was conceived as proof that Saudi Arabia could build something entirely new, a diversified, tech-forward tourism and innovation economy that doesn't depend on what's under the ground. There's also a geopolitical dimension. Positioning the country as a hub for advanced manufacturing, tourism, and technology gives Saudi Arabia leverage and relevance in a global economy that's increasingly organized around who controls emerging industries, not just energy reserves. A wildly ambitious, headline-grabbing project like the line generates exactly the kind of global attention that supports that positioning, whether or not the project is completed exactly as originally envisioned. Which brings us to an uncomfortable but important question. Does it actually matter if the line gets built at its original scale, or was generating this level of global conversation at least part of the point? It's worth being fair here. Major infrastructure projects around the world routinely get scaled back, delayed, and reworked from their original announcements. That's not unique to Saudi Arabia. What makes the line's situation more visible is the sheer scale of the original ambition relative to the reported reductions. When you promise 170 kilometers and multiple reports suggest the near-term reality might be a small fraction of that, the gap between vision and execution becomes the story in a way that's harder to avoid. Now let's talk about the engineering itself, because regardless of how much of it ultimately gets built, the concept raises genuinely fascinating structural questions. Building a continuous 500-meter-tall structure means dealing with wind loads across an unprecedented continuous surface area. A conventional skyscraper has to manage wind from essentially any direction, hitting a relatively compact footprint. The line's mirrored walls create what's effectively a giant continuous sail, and engineers have had to consider how wind behaves differently when it's channeled along a 170-kilometer corridor rather than around an isolated tower. That funneling effect, sometimes called a canyon effect in urban planning, can actually increase wind speeds at ground level rather than reduce them. There's also the question of a livable interior climate in one of the hottest regions on the Earth. The design relies on the height and orientation of the structure to create natural shade across the majority of the interior space for most of the day, reducing the need for the kind of brute force air conditioning that dominates Gulf architecture. Whether that passive cooling strategy performs as modeled at full scale across a structure this size remains one of the genuinely unresolved questions independent engineers have raised. The foundation work is its own enormous undertaking. Sections of the line's planned route cross mountainous terrain in the northern part of NEOM's territory, meaning construction crews haven't just been building foundations for a 500-meter structure. They've had to blast and grade through solid rock in some sections, while managing very different, sandier soil conditions elsewhere along the route. That kind of geological inconsistency across a single continuous structure is almost unheard of in a project of this type. And then there's the transportation spine running through the middle, the high-speed rail line that was meant to be the entire point of not needing cars. Building a rail system that can move people the length of a linear city in 20 minutes requires speeds well into high-speed rail territory, all contained within an indoor, climate-controlled tunnel running the length of the structure. That's its own massively complex engineering undertaking layered on top of the building itself. So where does this actually leave the line going into the back half of this decade? Based on current public reporting, a significantly scaled-back initial section does appear to be under active construction, with foundation work, structural steel, and early-phase infrastructure visible in satellite imagery and site photography. Whether that initial section eventually extends towards anything resembling the original 170-kilometer vision is at this point an open question that even people close to the project don't seem to have a firm answer to. What's clear is that the line has already accomplished one thing regardless of its final built form. It's become one of the most discussed pieces of architecture and urban planning of the decade, a permanent reference point in conversations about ambition, feasibility, and the gap that can open up between a rendering and reality. For now, in the desert of northwestern Saudi Arabia, the walls are going up, just not quite as fast and not quite as far as the original renderings promised. And as always, if you enjoyed this video and want more from the definitive channel covering the world's biggest infrastructure stories, make sure you're subscribed to Apex Infra.